a functions question, and it's using the inverse function, which we can see straight away from the -1 that's given to us in a few of the questions. So first of all, it's always a good reminder to remember that with functions and with inverse functions in SLAI, f of x is equal to y, and then on the inverse function, you're just swapping the x and y over. So essentially, it's the same function, it's just the input becomes the output and the output becomes the input. And that's really all we need to know. So we're probably going to need that within this question. So the first one, we're finding f of -1, so that means the inverse function of 4. So to answer that question, if we're working out the inverse function of 4, so that means that the input into the inverse is 4, that's the same as saying when is the output 4 of the original function. And the output here, this is the output, and this is the input. So the output is 4 when x is equal to 3, and therefore f minus 1 of 4 is also going to equal 3. So that's the first one. And then the second question, solve nx is equal to f of x. So that means when is the input equal to the output? So the input and output are equal when x is equal to 1. That's the only time that the input and the output are both equal to each other. And then the third part of the question, part C, is asking us when is f of x equal to f minus 1 of x. So what that means is when is the input and output equal to, when I swap it round, the output and then the input. So it's a bit of an awkward one to think about. And the easiest way to work this out, I think, is through a graph. So my coordinates are 1, 2, 3, and 4. 1, 2, 3, and 4. So my original f of x values I'm going to do in blue. And the f of x values are, the first one is coordinate 0, 2. So that's this point here. And then I have coordinate 1, 1, coordinate 2, 0, coordinate 3, 4, and coordinate 4, 2. So they're my 5 kind of coordinates for f of x. And then I'm going to do the same again, but this time for f minus 1 of x, so for the inverse. So that means that the input and the output now swap over. So I've got as an x value 2 and as a y value 0. So x value 2, y value 0. 1, 1 still becomes 1, 1. And then 2, 0 becomes 0, 2. So that's this one here. And then I have 4, 3 for this coordinate, 4, 3, and 2, 4, which is this one up here. And you can see there that there are 3 times that f of x is equal to f minus 1 of x, and it's these 3 coordinates here. And so my answer is when the 0, 2 becomes 2, 0, when 1, 1 is equal to 1, 1, and 2, 0, which becomes 0, 2. So the middle one there maps onto itself. This one kind of goes to this one here, and this one kind of goes to this one here. So there's 3 times, and it's only asking for the x, it's not asking for y. So it's when x equals 0, when x equals 1, and when x equals 2, which is the x is 0, x is 1, and x is 2 part of my table there. So that one's quite an unusual question, but it still works in the same way. And I think the easiest way of answering that is to have it graphed.